Yeah, welcome back, everyone. Today I'm going to be talking a little bit more about, well, me. I had some questions about, what am I doing, what do I do, and like where my skill sets came from. So I'm just going to tell you guys a little bit about my current career path and how I know some of the things that I know. So I work for a public sector government agency here in California. I'm not going to name drop what because it's not that important and I don't really want to get in any trouble for anything. So I'm just going to leave it at that. I work for the government and I am a research data analyst too. In public sector here, we have various classifications. The classification names are the same usually across the state with varying job duties. Each person for those positions has a duty statement that outlines like what do you do in this exact position. And some of the stuff that I do is basically like if you took it into the private sector, the kind of stuff that I do is basically what a data engineer does. I write code and software in a variety of languages, and basically I just connect information systems, queries to front end. Yeah, I do a lot of weird stuff. I don't really use Excel much anymore. I'll make a video coming up soon about like why R is vastly superior to Excel, and it's like the next stepping stone for analysts or people who are really serious about data analytics or data science. But for me, what I tend to do in a day is I write SQL queries. I write in both T and PL SQL. The PL SQL I deal with is kind of like the way it's implemented is like a proprietary language that uses PL SQL but has some stuff based on like C++, and it's kind of a nightmare. But I've been working on that for a couple months now, so it's starting to like pick up, and I can do some really cool stuff with that. But I write queries and I return data sets to be used by front-end applications written with the web stack. Primarily, we're using Angular right now, and I write these queries, I connect them to the front end in a way, and we display, data about patient records. So I write these. I'm working with other people, and we make these web apps in medical software. And I write a lot of the back-end code for getting data sets and optimizing these queries. I also write R reports. But that's a lot of stuff that I do now. And honestly, I never went to formal training or school for any of the programming, computer science related material that I know. So how did I learn all this? So when I first started my career, I've been working for the public sector for, I think, almost 5 years now. So good long time. Most of my career has been in the public sector. My entire full-time, like working full-time, has all been in the public sector. I started off with my agency, and I've been in the same agency the entire time. I started off, and I was just a brand new, low-level peon. I was the lowest you can be. I was in the bottom of the rung. I was on the bottom rung of the ladder. And over time, I mean, I actually was overqualified a little bit for the position I was in, given that I had like finished an associate's degree while I was in that position, and that's like the only degree I have right now is an associate's. I have a couple associates, and so I went from that position, and because I like to think I'm a very hard worker, and I'm always like ravenously learning. I'm a voracious learner, and I love to read too, so that helps. I started getting interested in like my work and always trying to do things better or be more efficient. Like I was that weird person where my low-level menial job was just scanning paper into an electronic system. And so I was like, okay, if I put the scanner on the floor, then the angle of where I have to grab the papers on my desk and put it into the scanner is minimized, and I don't have to reach, so I can save my shoulders. And now, how can I like copy this number? Oh, I can keep a Post-it note open on my sticky note application on my computer, and I can copy and paste with hotkeys, and then copy paste, and then have the papers stacked up and ready in alphabetical order by document type. And like I was crazy. That's just basically how I approach my work. I'm super OCD. I'm very meticulous and organized, and when it comes to work, I like to think that I'm very, very well suited and organized and OCD when it comes to work. But when it comes to like social aspects of like life and dealing with people, I'm about as dumb as they come. My girlfriend's laughing at me right now because it's very accurate. Is it not accurate?
It is.
It is, she says. That's very accurate. I am like, my element is work, data science, programming, code, dealing with computers and machines. She's laughing again. But when it comes to dealing with people, I'm pretty much stupid. Um, so I was working my low-level job, and then immediately I started getting noticed because if you work hard in the public sector, you do, for the most part, seem to move up because people recognize that, yeah, you're in a government job. Yeah, you're unionized. Yeah, you could slack and just get by. But, I'm ambitious and I actually care about my work. I want to grow my skills. I want to do bigger things and have more impact and, contribute to, making public sector government and governance better. There is such a thing as good government if it's done right and you can contribute and help things with civil service. There's several groups that I work with that deal with like writing code and developing web apps and dashboards and things to help people in a civil setting. There was one of the groups I'm in. Somebody made like a dashboard or some list or something of like once all of this Corona COVID stuff happened, they had this compiled list of all of these businesses that were still doing like takeout food, so that way you could support the businesses by having this long list. And or some of the government agencies that currently have code hosted on GitHub, like I'll just go and contribute to those repos and help things that way. So there's some good stuff you can do in government if it's just open, collaborative, and people are actually in it to achieve a better social outcome. And so I try to be more on the optimistic side of government. I mean, I'm not, blind to the cons of government, but given it's my profession, I kind of try to just, stay optimistic because it's where I work. So I quickly got promoted out of my low-level positions, and I kept moving up. And when you get up higher, you have more encounters with data and having to do analysis and reports, and you're doing less of just like, I file papers, or I scan documents, or I go get the mail. It's less of the menial tasks and more of the things that you actually have to use your brain because you're getting up, in higher positions. You're becoming more of an analyst. You have to grow your analyst level capacities. There's like four main levels of government, I would say. At least in my experience with the state level government, there's like four main levels. You have like the low level, like task-driven positions, like your assistants and your technicians, and they do tasks. They get a list of tasks. They have itemized, like, you need to do these duties. These are your duties. You complete these daily. You complete these weekly. You complete these monthly. And that's what they do. They do their job. They have task-oriented work. The next level is analysts. And this is like a very large like scope of work, is that you have like your intro analysts. So when I promoted from assistant to tech to analyst, I was a low-level analyst, and the analyst could have several levels and several different classifications with varying levels of complexity, job duties, and specifications, etc. It's a very wide part of the spectrum, is the whole analyst level of things. And from there, you have to start actually, like, you have to use your brain. You think, you analyze things, you create, you design, and you start learning or have to learn new skills, statistics, programming, how to use Microsoft Office. From like basics, yeah, you need to know Microsoft Office because that's what everyone's using. And so you get good at that, and then, but you need to actually know how to analyze data. You need to be like literate when it comes to data. You need to know about like, is 50% bad with this thing? Well, I don't know. What's the proportion? Is 1/2 bad, or is 200/400 bad? So little things like that about knowing how to understand data and being able to interpret those things, conceptualize it, report on it, convey meaning and significance to other people. These are all skills that need to be acquired in the analyst level. And I worked through several levels of analyst. I've been like the staff services analyst. I've been I was like A, B, C, and C is the highest, and I went from B to C, and then I went to a senior analyst, and now I'm something called a research data analyst, and I'm a research data analyst 2, which means it's like a senior analyst but a little bit higher, and you actually are expected to have somewhat skills with like statistics or programming or more advanced, and so I'm like moving upwards in the analyst series. But beyond me, like after analyst, it's like then you have to develop in a completely new skill set. Like you can only go so far in rank and file. Then you need to get into like management, and in management, you got to develop a whole new skill set because you're not doing the work, you're managing the people doing the work. You have to have, plans, you have to deal with other people collaboratively, other units. You need to, deal with executives, figure out what they want, conceptualize that, convey it to your team, organize your team, assign tasks to your team, and then, get the work done. And then after management, it's executive level. You're so removed from the work, but you have the vision. You tell management, this is what your goals are. This is what you want to have happen. Here's how I want you to implement these things. And then management takes that, disseminates that to staff. Analysts will think about things and create stuff and whatever, whereas some of the lower level positions will just receive task-based assignments, etc. You can see how this type of stuff flows. So I'm in sort of the middle to upper range of analyst level series right now. And what I do right now, I've developed my skill set from my low-level positions. So when I started becoming a tech, I started working with Excel more. I got really into Excel. I'm like, oh, this is fun. I can have all these cells. I can change formatting. I can input data into here. Ooh, formulas and functions. This is cool. I can manipulate and transform stuff. I can start connecting a lot of really cool different formulas to achieve some not normally used results. Weird things like, oh, I'm typing out a string of text, but it's a formula of just text, or I can do a formula calculation, 1 divided by 2, 50%, and then I can add another formula to that, add the n formula. Inside the n formula, you can give it a string and give a intra formula comment, just weird stuff. I figured out a lot of quirks and interesting stuff about Excel. I got really into it. And to the point where I even got upwards of, I think I have 113 certifications or something in Excel. I have a lot of certifications. I think I have 280 in various different things, different software, different programs, certificates, certifications, classes, training, whatever. I have most of them, the bulk of them are in Microsoft Excel. So I figured out a lot of things about how to use Excel. And beyond just using it and writing formulas and functions and just the actual built-in functionality, I also learned the scripting language for Excel, which was my first major foray into programming. I mean, I was one of the generation that we grew up working on our MySpace pages and modifying the HTML and CSS. And so working with MySpace, that was my, programming, when you're really just messing with HTML and CSS. But I got into the actual scripting language for Microsoft applications, which is VBA, or Visual Basic for Applications. Pretty much the red-headed stepchild of programming languages and one of the most hated languages in the world. But, it actually did serve some good business use cases in my particular agency. It's not widely used, therefore it's not widely supported, which means that, basically you are the sole owner of your applications, and if you go away, they go away, and sometimes people don't like to have that kind of user dependence, especially in state government where people move around a lot. But I made several applications. I would create full data analysis and reporting applications that would produce output, save files to your desktop, generate emails with your Outlook, attach the files to the email, and create summary reports, just a single click of a button. You drag your data in, you click a button, everything is done, it's all calculated, saved as a PDF, attached to an email, with a distribution list to everyone that you want to send this report to that you can update in the actual program. You click send, it's 2 button clicks, and your people who do your reports, it's so easy. Hours saved, and just all kinds of cool stuff I've done with VBA. But again, it is not a really good language. I mean, it's really good for what it's meant for. It's good for automating Microsoft applications. And I've done some really cool stuff with Outlook and Excel with it. And you can do some really amazing stuff. I've seen people who embed full-on video games or make some really crazy, awesome applications built in. And with the Rubber Duck IDE, which is a project on GitHub, I think, but made by Microsoft staff, it's kind of like a modern IDE layer over the old VBE, or Visual Basic Editor, in Microsoft applications. It makes it somewhat bearable. There's unit testing, there's all kinds of cool stuff that you can do. But after I started moving more into several higher level analyst positions, I started seeing Excel is a large learning curve, and it's a GUI application that mixes formatting and data entry and your actual analysis all in one place. And unless you like pick up that you should have separations of concern, such as like a tab where you have just your raw data, just a dropping place, you don't touch it after you drop it there. Then you have another tab where you actually do your transformations on your data. You filter it, you sort it, you add some calculations, you add some new fields, and it's a data table now. It's actually a table object in Excel. You could then take that table and then put it into a pivot table and create some sort of pivot analysis, and then use another tab for your final summary report face, and have that face reporting tab filled with get pivot data functions that pull that data fields from your pivot table, or so many different ways that you should just not have everything all in one tab, and always to just maintain a raw data tab. But then what happens if you save your file? It gets corrupted, or you accidentally delete it, or just an unholy nightmare of things that just come with dealing with primarily a GUI application for data analysis. Not great. And so over time I figured that out, and as I started getting more senior in my analyst roles, I found R programming, and I'm like, oh, this is interesting. Really what got me into it is just, it was so easy to create really good looking reports with very little code, and even code that doesn't have to be super complex or like really statistics heavy, because at that point I didn't really know anything about statistics all that much, just based on what I picked up from a stats class in college. And I got into R Markdown primarily, and I was just like, oh, this is really cool. It's really easy to just create very good looking output with R Markdown. So I started looking into R a little bit, and then to get my current job, I actually had to go back to school to take a stats class, because I dropped my stats class in college because I really didn't, well, half the class dropped it because the professor was really bad. But I went back to school, took the stats class, and decided to just, two for one. So I took the stats class to learn stats, and also just to get this job. But also, I decided to use the class as an opportunity to learn more about R. They said you could use several different options. You could use an Excel add-in, you could use R, you could use SAS or whatever other languages, and you could use whatever you wanted to perform the exercises and take the tests for the class. So I chose R. And through that, I actually learned a lot of base R, which is like, it's like learning vanilla JavaScript before you learn a framework. I learned base R before starting really getting into like the tidyverse and other like R packages. So I learned like some of the basic stuff. And I really started to see like R is really good. And then I started really researching it. I dove deep into R related content. I really got into it, and just also learning other languages. And with R, like the reasons why it's far superior in like programming and taking a programmatic approach to data analysis versus like Excel is the superior method, is simple things like reproducibility, version control of plain text files, given that it's a programming language. You have an analytical pipeline, and things like unit testing and encapsulation in like a package. So using R for like a packaged analysis. And I chose R for this, not Python, because R it's so easy to create good output with R. Shiny, ggplot, R just has some really great tools, and R has the best stats libraries, period. It just does. Python does not beat R when it comes to the breadth and depth of the statistics libraries that R has. And the tooling in R, in the IDE RStudio, is just fantastic. It is great. The syntax for R is a little bit weird. I think most of R, a lot of the base R stuff is actually written in Fortran, but it also has a lot of stuff that deals with C++ interface, so you can actually write C++ functions when you need to get extra speed. R is single-threaded, so it can be slow, which is why we have C++ stuff. But also one of the great things about R is just that it's a great intermediary language. It can connect to so many different things, especially with R Markdown that connects with Pandoc in RStudio, different language engine supports with Knitter. You can use bash scripts and awk and R code all in the same document, output to an HTML format, then with code chunks for CSS and JavaScript and custom either Markdown or HTML stuff in R Markdown. You could have so much stuff in a single R Markdown document that it is so flexible that you can really just do whatever you want with R. So needless to say, I'm a big R nerd. I've spent hundreds of dollars on R books. I'm subscribed to newsletters. I'm on the RStats Twitter hashtag. I follow several people in the R development community. I've written my own R package. It's published to CRAN, the Comprehensive R Archive Network. And I chose to go with R because of all of these things. And I started really getting into like data science and seeing like data science, academia, and like reproducibility of your analyses, and just taking a programmatic approach to things. So I wrote a whole like write-up on like how I approach analyses, and it's on my GitHub under like R workflow. And it's like, here's like how you would easily load packages by like giving an array of packages to a variable, and then seeing using that array to like, iterating over it, which packages are not installed, take the ones that are not installed, install them, and then you can use that package variable with some stuff with bibliotex, and then actually have a citation file generated based on the actual packages you use, so you can cite your open source packages, and then you can actually use your in-text citations using YAML, how to do an analytical workflow by creating a packaged analysis, a changed log, using Git version control, all of this stuff. I went deep into data science, R for analytics, and it's basically like my favorite language. And it's just really cool, all the stuff you can do with it. And the reason why I chose it over Excel and why I actually still try to implement it at work all the time is that you can easily have code in a single code file or just a package. And you can have an R package. You develop an R package, you have several directories, you have your code, you have your raw data, or you have your scripts that actually give your main R Markdown report file all of the completed, imported, transformed, and validated data, tables, sets, tibbles, data frames, however you want to like output your data format into your main report. Your main report can take those completed data sets and actually structure them and have some charts and plots and visualizations, data tables, summaries, whatever you want. Or you could just do it all ad hoc in the command line if you want to just do it all in the R command line. Or you could have an R Markdown document where you just do everything fresh, or just have your scripts import your data, have your R Markdown document, and you just iterate. You just do some transformations, apply a logarithmic scale here, do your median there, or whatever. And it's just great because you can do version control on the plain text. You can you can make your analysis a package, so which means you can just pass the entire package to somebody else with a snapshot of your current system, all the current library versions, all of your code, all of your data, exactly how it was at that single point in time, which means for the scientific and academic community that it is a reproducible analysis. Somebody can take your scientific findings, exactly how you did them, with all of the software, with the versions that you used, with the data, exactly how you did it, and perform your analysis and your calculations exactly how you did and reproduce your analysis. There is a reproducibility analysis crisis in academia and science right now where like 80% or something like that of scientific studies don't meet muster. Like they are not reproducible. And so it's a really great boon to the academic and data science communities. So I chose to really deep dive into R and started really getting into programming and code. And now I like learning code for fun, but I also like to have like a reason for learning a language and projects to then learn that language. And if I can get a good project that gets me into a language that I really enjoy and I can see a reason to stick around with it, learn more about it, I will tend to just really dive in head first. And so like recently with my Flash script program, I'm going back to school and I wanted to write a flashcard program for myself in the terminal because I couldn't find any good ones written in Bash, and I didn't want something as super heavy and having to use like a language like Python to learn all of that complexity. I wanted to just use something simple that I sort of already understood a little bit about and in the command line, so I chose Bash because I already have this system. And by getting into like this Arch Linux system and using Bash and all these command line utilities and window managers, like my productivity is just like skyrocketing. All these terminal applications, task management stuff, I'm geeking out hardcore every day. But I wrote it in Bash, and I really wanted to learn Bash really well because it's so easy to do like a lot of customization on Arch Linux and Linux in general by using the Bash scripts, Bash language, the command line, the built-in utilities, and it's also really good for data science if you do a lot of stuff on the command line, like with awk, or with awk. And so I learned Bash decently well. I made a video about Bash, and I'll probably put a card up there or something, but it's on my channel. I made a video about like intro to Bash programming, and I wrote a Flash script in Bash, and Bash is a crazy language. Like it is crazy, but it's really cool. And a lot of the stuff you can do with the built-ins is really fun. And that project really helped me learn Bash. And now I'm learning C just to do some more low-level stuff. write command line applications, modify the suckless software for suckless.org. And that's kind of like the stuff I do for fun. But like at work, I typically just write, query code. Sometimes I do some R reports, dealing with the front end web apps. And yeah, it's basically like a data engineer is how like I would probably be classified if I was in the public or the private sector. So I'm going back to school right now for a data analytics degree, a bachelor's, because I still only have an associate's. Basically, I'm self-taught. Like, I take courses and stuff, but most of the stuff I learn by just messing with projects and, watching YouTube videos, tutorials, and messing around with stuff. And when I got into Linux, like really got into Linux, I've had an Ubuntu laptop forever, and I basically just used it to like hold files. But when I really got into Linux and Arch Linux, like last year, almost a year ago now, I really started getting into the command line, really started getting into like low-level system programming through C, through Bash, and just seeing all the cool stuff and learning like low-level parts of a computer system. And just a lot of the cool stuff that you can do with a computer system that's more open than like Microsoft Windows. Tiling window managers, Task Warrior, just command line options, utilities, command line programs, apps. It's just been a blast. And so I basically just spend all of my free time learning new programming languages, building stuff, playing around. I got several repos on GitHub I maintain, and got my website I built myself, which is probably not going to be there forever. But yeah, I kind of just teach myself a lot of this stuff, and I'm really interested in like data science and academia and scientific reproducibility and taking a programmatic approach to all of these different things, using R a lot for data science. And so that's why I have a lot of R content on my channel, is that I'm really big on R. And so I will definitely be doing more on R, learning a lot about it. And that's basically how I got where I am right now. I'm a research data analyst too, make a good living, and I'm basically a data engineer. And I learn languages, use them at work. Basically, a lot of my free time hobbies help me do better with my job, just because, learning multiple paradigms of programming, like procedural, functional, object-oriented, low-level systems, query languages, just all the different stuff that you can learn when it comes to computer science, code, and programming. It all builds on itself. Being a generalist is often far more superior to being a specialist, because if you only know C programming, then you're only going to know low-level systems programming. Yeah, you're going to know a lot and be able to do a lot with C, but if that's the only thing you know, you're not going to know where to start with query languages. You're not going to know where to start with something like R, or how to deal with the web stack, or like just having skills in a variety of different programming languages, paradigms, and just different tools, and understanding all this stuff really helps make you a well-rounded person, not only for just being able to actually create useful things, apply those skills in a work setting, but also it makes it easier to see how things are connected, like how different languages implement different or similar structures, like an if statement or a case statement, or variable assignments, or what pointers are, and just seeing all this stuff build on top of each other. It's really easy to put things together and then learn new languages, because you see how the things are, what the commonality is. Most languages have if statements or case statements or loops or variables, and knowing how those things are implemented becomes really easy to pick up when you start a new language, because you're already used to the logical nature of these things and the syntax of other languages, that it's like, oh yeah, this C language, yeah, I've done a little bit of JavaScript, and braces, semicolons, variable assignment, yep, looks familiar. It becomes a little bit easier to see parallels across languages and just being well-rounded. So like if I was going to give advice to people, I would say, if you're doing a lot of things in Excel, that's cool, but try to move to a programming language, Python or R. I highly recommend R because it's portable. It's easier to install than Python. It's easier to just hit the ground running with R. RStudio is a great IDE, and even if you're on lockdown systems, you can easily install portable versions, and it's just easier to get output. It's got better stats libraries. R is an amazing tool, and it's still like one of the go-to languages for statistics and data science. I would say move away from Excel, go to R, learn more things about computer science, about programming, and more different paradigms, and play around. try other languages, try other projects, learn things for fun sometimes. You don't have to memorize all of it. And just, yeah. And learn Vim. Learn Vim. Vim is awesome. So I think I've talked a little bit too much. Enough. Yeah. So I'm just going to leave it at that. Really like my work. I love programming. I love all this computer stuff, which is why I have this channel. It's kind of just like, this channel is more of just like, I want to actually build like a small little like community of people who like code and programming. That's why on my live streams we usually end up just talking about programming languages or cool stuff we're doing with C or whatever right now. But yeah, it's just me talking about the nerdy stuff I'm into and trying to tell people how to try or use other tools and do things in R. So before I go, thanks to Devin, who's my current patron on Patreon. Thanks for supporting the channel. And to everyone who watched this long spiel about me, thanks for sticking around. Thanks for watching, and bye.